In the last video, we looked at proving triangles similar by the angle-angle similarity postulate. Well, there's two other ways to prove triangles similar. And the first one is the side-side-side similarity theorem. And it says that if three sides in one triangle are in the same ratio as three sides in another triangle, the triangles are the same shape but different size. So we're talking basically about a scale factor. And a scale factor is what we can use to compare something small to something a little bit larger. Say, for example, if you've ever picked up a model car, and it might have a scale factor of 1 to 12. And so that means the scale model might be an inch, and so that means the actual item would be 12 inches long. So let's go down here, and we're going to make some comparisons in these particular triangles right here. What we're going to do is we're going to kind of match some pieces up. Okay, it says, is either triangle DEF or GHJ similar to triangle ABC? This is our main triangle we're comparing. Okay, now I put that in blue. So what I'm going to do in triangle ABC is I'm going to list the sides in order from smallest to largest. 8, 12, and 16. Now what I want to do is I want to compare the measurements in triangle DEF to it to see if all the sides are in the same ratio. Okay, so what that means is I'm going to make a fraction out of all these right here. So, not tool's not working great. Let's do this. Okay, so underneath the 8, the smallest side in triangle ABC is going to be the smallest side in DEF, that's the 6. And the middle side is the 9. And the big side is the 12. So, do all three of these fractions reduce down to the same thing? Well, 8/6 reduces to 4/3. 12/9 can divide everything by 3, 4/3. 16/12 divide everything by 4, 4/3. Aha! Equal. All the sides are in the same ratio. 4/3 is a scale factor from the big triangle to this small triangle here. So we can say that these two triangles are similar by SSS. But let's look a little deeper. Because now let's go and compare the blue triangle to this last triangle that we'll color in green. So again, if we list the sides of the first triangle, 8, 12, and 16. So if we put the sides in order, in this green triangle here, the smallest side is 8. That's going to go underneath the smallest side here. The middle side is 10. The big side is 16. Now if all three of these fractions reduce down to the same thing, then the green triangle, HJG, is similar to ABC. And we can tell that they're not going to be the same because 8/8 is the same as 1. 12/10 reduces to 6/5, and 16/16 is 1. These are not the same, so the first and the third triangles are not similar. So we have the AA similarity postulate, the SSS similarity postulate, and now we have the side angle side similarity postulate. And what that looks like in this particular diagram is you have to have two sides, XZ and MP, in the same ratio, and XY and MN in the same ratio. And if the included angle in between here, if they're congruent by side angle side, the triangles are similar. So we have a congruent angle and two sides in the same ratio or proportion. Alright, let's dig a little bit farther into this. Alright, to do so, let's look at this. You are building a lean-to shelter starting from a tree branch as shown. Can you construct the right end right over here? Okay. So it is similar to the left end using the angle, measure, and length shown. Okay. So, let's see what we've got. We have a 53-degree angle and a 53-degree angle. There's the angles that are the same. We have a 6-foot side and a 9-foot side. So 6 over 9 is the scale between those two sides. Now we have a 10 and a 15. Well, 10 over 15, we need to see if those are equal ratios, and they are. They both reduce down to 2/3. Okay, so could we go ahead and construct things? The answer is yeah, we could use the measurements. So if we knew this side right here, this side over here would be would be in a ratio of 2 to 3. Okay? So this is SAS similarity in action. Last thing in this concept to share with you. Tell what method you would use to show the triangles are similar below. Okay, so to dig into this, here's what we have. Well, we have vertical angles right in here. So we have a pair of angles that are congruent. Now, this 9 right here is smaller than the 18. So if we were to try to match up this 9 with this 15 over here, 9 over 15. Well, with what's left, we have this 18, which is bigger than the 9, and so the 18 would have to match up with the 30. So we've matched up 2 small sides and 2 larger sides. So, do these have the same ratio? If they do, that's going to be enough to use SAS. So are these equal? That's the question. Well, 9/15 reducing fractions turns out to be 3/5. And 18/30 you can divide everything there by 6, and so that's also 3/5. So guess what? Triangles are similar by side, angle, side, similarity. You got to put the similar sign because we're not talking about SAS with congruent triangles. Okay, so we can make one last statement here. We could say that triangle ABC is similar to triangle. So A would match up with angle D, B would match up with E, and C is vertical with C in the middle there, so that we've got enough to prove it. And that's similar triangles. And we can deal with proofs with similar triangles along the way as well. See you next time.